Okay, so we're going to do the last two problems from section 1.5 day 1, just in case I didn't get to them in class. And then we'll move on to the day 2 problems that will help you get through that second homework. So we are trying to solve for x, and this is called solving other types of equations. And so for number 7, we can see the problem with solving for x is there's a 3/2 power that is put on the variable x. First thing we're going to do is isolate x to whatever power it's raised to. And that means we're going to have to add 8 to the right-hand side and then divide both sides by 4. So we've isolated the thing that's raised to the power. It's something we've done before. And what I'm going to do is try to get rid of the power in 2 steps. So the power is a third power and a square root. That's what 3/2 means. Third power and a square root. So I'm going to get rid of the square root first by squaring. When I square the left-hand side, the square undoes the square root, and I'm left with just a cube. And then on the other side, I'll have 2 squared, which is the number 4. And then I can take the cube root of both sides to get rid of the cube, and I'll have my answer. X has to be the cube root of 4 in order for 4 times it raised to the 3/2 power minus 8 to be 0. Next problem is a little bit different. It looks like, but it's a 2/3 power. And there's a little trickiness with this one because this is a square and a cube root instead of a cube and a square root. So it is already isolated. The parentheses are surrounding the base, and we've got the exponent. We will get rid of it with those same 2 steps. We're going to cube, in this case, to get rid of the cube root. And then I'll just have x squared plus 2 squared equals 9 cubed. And so I can multiply it out, or I can leave it as 9 cubed, whichever I want to do right now. And I'll show you why 9 cubed might be a good way to keep it, because now I'm going to take the square root of both sides. Now, taking the square root of both sides means I need a plus or minus. Taking the cube root does not mean that, because the cube root of a negative is negative, and the cube root of a positive is positive. But with a square root, we know that you can square negatives and make a positive. So we have to be careful that we say plus or minus. So the square root undoes the square. And now I've got to take the square root of 9/3, plus or minus. And so the reason why keeping it as 9/3 is nice is we know it's 9 times 9 times 9. And each of or 2 of the 9s can be grouped together as a pair. And the other 9 can be split up into 3 times 3. So what we're going to do is pull out a 9 and pull out a 3, and I'll have 27 on the right-hand side. So if you don't like that, you could have put it in your calculator to figure out that that is what you get when you do the square root of 9 cubed. So now we have 2 problems, either x squared plus 2 equals 27 or x squared plus 2 equals negative 27. And again, isolate the thing that's squared by subtracting 2 from both sides. In Math 21, this will have no real solution because you can't square a real number and have it end up negative. But here we'll have 2 solutions, plus or minus 5. So that's finishing off those last 2 problems from the previous page. Now moving on to the day 2 problems, we've got a little bit more complicated problems in the sense that we've got fractions and we've got absolute value. So to start off with, when we have fractions and we're going to try to combine them together, remember we need a common denominator. So there's 2 over x is one fraction, 3 over x minus 2 is another, and this is a fraction, or could be a fraction if you write it 1 over 1. So if we get all 3 of these to have the same denominator, then we'll be able to pull together and have a simpler expression to solve. So looking at this, the common denominator we'd want to use is x times x minus 2, because there is no common factor between x and x minus 2. We're going to have to use that product as our denominator. So this fraction, 2 over x, is going to change because it doesn't have the x minus 2. So I multiplied the bottom by x minus 2. I'd have to multiply the top by x minus 2. So this is an equivalent fraction. Here, I had to multiply the bottom by x, so I'll multiply the top by x. And here, I had to multiply the bottom by x and x minus 2, so I'll multiply the top by that. So this is the number 1. It would simplify to that if I needed to, but I don't. I want the denominator to match the denominator to match the denominator. Because now that they have all of the same denominator, I could use a strategy to solve this equation, which would be multiplying by that denominator. Multiply everything in the top by that denominator. And what I'll get is just the numerators. So once they all have the same denominator, I know that if I put these two together, they'll still have that denominator, and the denominators will match on each side of equality. So now we're going to set the numerators equal. That is only possible if I remember that x can't take on the value 0 or 2. That was the domain of the problem. So now I have a little linear equation to solve. I distribute and distribute the x and the negative. And I move everything to one side. Actually, I'm going to move it all to the left so that my x squared will be positive. So I'm adding x squared. This is 5x. I'm going to subtract 5x. And I have my minus 4. So everything went over to the left. And then I can factor and come up with my two solutions, 4 and negative 1. And you can plug them back in for both x's, 4, and check and make sure it equals, the left equals the right, plug negative 1 in, same thing. So same strategy here. Get a common denominator, x times x minus 2. So I'm just setting up all 3 of my pieces. The first one I multiplied by x minus 2 on the bottom, so I'll do that on the top. The second one I multiplied by x, so I'll multiply on the top. And the last one I will, I have to multiply by x and x minus 2. And there was a 2 there already, so the 2 and the x minus 2. So same idea, they all have the same denominator now, so all I have to do is make the numerators solve that equation, that when I add these two together, it'll have to equal that one. And I then distribute again, move everything to one side. So I'm gonna, this is 4x, I'm gonna subtract 4x from 4x and get negative 8x and add 6 to both sides. I can divide everything by 2 and end up with this equation, and then I can factor it and get my solutions 1 and 3. Now remember, all of this only works if x is not equal to 0 or 2. But I came up with 2 answers that were not 0 or 2, so they should be good. So that's what we're going to do with fractions, get a common denominator. Absolute value. we have to remember that there are two problems to solve with absolute value. So remember when I said the absolute value of x equals 6, we had to think about two scenarios. We could have 6 or negative 6 and make that true. So we're going to do the same thing here. We're going to look at two different cases here. Maybe what's inside this absolute value is exactly what's on the other side. Maybe I could just drop the absolute value and this quantity would be a positive value and it would just equal that. So if I solve that, it looks like this. I've got to add 4x to both sides and subtract 6. I've got to factor, and I get 3 and negative 2. But the other possibility is x squared minus 3x, this quantity, is actually the exact opposite of the right-hand side. Just like here, the exact opposite of 6. So this value is negative 6. So I'm saying this value is the opposite of that. And that would mean that I'm going to get different answers because I got to subtract 4x and add 6, factor, and come up with 6 and 1. So it looks like I have 4 different answers that could be the solution to this. The problem is only one of these and one of these really works. Because of the plus or minus idea, we're going to have a little bit of an issue because when I go to plug in and check, 2 of the answers are going to make the right-hand side negative. And that is not going to be a solution because absolute value cannot give you back a negative answer. So we need to figure out which one of these would make negative 4x plus 6 negative. And that would be 3. If you plug 3 into here, you're going to get negative. And so that makes this what we call an extraneous root. It is a root that came from solving the way we needed to solve, but it gave us an answer that doesn't make sense because the absolute value cannot equal negative 6. So we're going to throw that one out. And then in this case, the 6 would make the right-hand side negative 18. So we've got to throw that one out. So the only two solutions are negative 2 and positive 1. And again, I'll let you take the time to plug them in to negative 2 in everywhere there's an x and 1 in and make sure you can see that it is a solution. So same idea on number 4. I've got to go 2 different ways. Either x squared minus 3 equals 5x minus 3, or x squared minus 3 equals the exact opposite. So negative 5x plus 3. So solving this one, if I move everything over to the left, I'm going to subtract 5x and add 3. I'm going to end up with that. Factor out my x and get my two solutions, 0 and 5. Here I'm going to add 5x and subtract 3. I'm going to factor it, get my two solutions, and now I just need to see which of those are extraneous. Which of those would make this right-hand side negative? So I can see here that 0, if I plugged it in here, would make this side negative. And over here, it would be the negative 6, because this would be negative 30 minus 3. So throw out my two extraneous roots, and I have the two roots that actually will solve this. So use that as you work through your homework on those type of problems. We also are going to branch out into a new kind of interest here. This is called compounding interest. So if you remember before, our interest formula looked like this. Interest was simple interest, and you took the principal times the rate times the time it was invested. And it just got interest got calculated at the end of the investment. Now our interest is going to get compounded every certain number of times a year. So maybe every month, or maybe every week, or maybe every year, but for a number of years. And what tells us how many times it's compounded is this n. So n is the number of times that it's compounded in a year. So if it's monthly interest, n would be 12. If it's semi-annual interest, n would be 2. R is going to be our interest rate like it always is, and T is going to be the number of years we invest as it always is, and P is the amount that we invest. So this is just our new idea of N. So in this case, if you deposit $15,000 in, that's your P, and you're guaranteed to receive $40,000 at the end of this investment, that's going to be your A. So P is the beginning balance and A is the ending balance in this equation. And T would be 20 because it's 20 years. And things are compounded quarterly, so that means 4 times a year. N is 4. So we're going to plug in everything we know here. A, P, R, interest rate, we don't know, right? That's what we're trying to find. What was the interest rate? That's the question. So R, I don't know. N is 4. N is 4 again, because N is in the equation twice. And T is 20. And now I've got to solve for R. So that's why it's in section 1.5, because there's a lot of stuff going on with R. But the first thing I'm going to do is divide both sides by 15,000. Because if I divide by 15,000, I can get this quantity where R is to a power isolated. So I'm going to take 40,000 and divide it by 15,000 and get 2.6 repeating. So that's not a really nice number. I'm going to turn it into a fraction, and 2 2/3. That's a nicer number. I'm actually going to call it 8/3, just so I don't have to write 2 2/3. And now I'm definitely going to need my calculator, because in order to get rid of the power of 80 that's on this 1 plus r over 4, I'm going to need the 80th root. Now, it's not something we've done before, but 80th root undoes the 80th power. And on the other side, it's an even root, so technically I need a plus or minus, but we're not going to use the minus because it won't make sense to have a negative rate. So I need to take this number I have in my calculator and raise it to the 1 over 80th power. That's what the 80th root is, the 1 over 80th power. And then I get this big decimal number. So I'm just going to put it down approximately, but I'm going to keep it in my calculator because now that is equal to what was inside the power of 1 plus r over 4. And so to solve for r, I'm going to subtract 1 from it. And then I'm going to multiply it by 4. So I subtracted 1, and then I multiplied by 4, and now I know my rate is 0.049. That's the magic number that will turn 15,000 into 40,000 in 20 years with interest 4 times a year. And so we're just sort of unpeeling things just like we did before, getting rid of the power, getting rid of the 1, getting rid of the times 4, all of those things to come down to our answer. And that is the end of section 1.5. Now, I know that's a lot of material. It's a lot of things to think about, but I want you to use that over the weekend to get through the 1.5 homework, and we'll talk about it when I get back.